All right, here we go. Okay, so for those of you watching on the video, you're just going to have to take your own notes, write everything on notebook paper, and since your classmates are here, I'm going to go as slow as I normally would during a regular lesson. So what we did the past few days was, like I said earlier to those of you who are already here, we were solving for the theta in a problem. So we're going to do the same thing, but we're going to go back to the old directions of 0 to 2 pi. So what we did on Friday was we went ahead and if there was something nasty inside, we had to add a pi n or 2 pi n. If they were next door neighbor angles, you went right to 2 pi. If they were vertical angles, you went to pi. So we're going to do the same thing in all of these problems, but now we have to do that and then narrow down our solutions. So you always, if you have something like a yick inside, what I called the inside, this 2 theta, this 1/3 x, if you have a yick inside, you have to start with that. And then we're going to narrow down our answers to the ones on the unit circle. So I'm going to show you by example, and when we get to the part that's new, I'll let you know and I'll go a little slower. So for the first example, 2 sine theta equals the square root of 3 over 2. Remember what we did was we ignored, on Friday, we ignored this part and we just talked about where the sine was radical 3 over 2. So, sine's positive here and here, right? Even though we're recording, remember it is live class, you guys can still talk to me, okay? All right, so questions on that? All right, so that's where it's positive. Do you know which angle goes with the sine being radical 3 over 2? That's the y coordinate. It's got to be pi over, remember? Pi over 3, right? Because it goes 1, 2, 3 on your unit circle. And that makes this 2 pi over 3. And these are next door neighbor angles. So if they're next door neighbor angles, you're technically going to have 2 answers. The stuff inside, 2 theta, that's what we did on Friday, equals 2 pi. Actually, let me start with the pi over 3 one. Pi over 3 plus 2 pi n. And then I'm going to have a second answer, that's 2 theta, the stuff inside, equals 2 pi over 3 plus 2 pi n. Now remember, that's not your answer. You have to get what the theta is. So does anybody remember how we get the theta by itself? Scott?
We multiply by 1/2.
Good. So everything. So again, this is nothing different than what we did on Friday, right? So theta is going to be pi over 6 plus, this will end up being pi n, that'll reduce. And this one is theta equals 2 pi over 6 plus pi n. And what I talked about on Friday was if it does reduce, you want to do that. So this one reduces to pi over 3 plus pi n. Do you have any questions on how we got those answers? Because those were exactly what we did on Friday. Okay, now what you have to do is you have to find the ones of these answers, because these are all of the answers in creation. You have to find which of these actually fit on the unit circle. So your first answer is always the angle that's starting the problem. And then what you're going to do is you're going to add different n values. N is 1, n is 2, n is 3. And as you get better at these, you'll get better at finding the answers in terms of doing them in your head. So here's what I have to do. Your first answer for theta is going to be the thing that you have, pi over 6. You always start with that one. That's on the unit circle. Basically, this one, if you want to write like a note, this is when n equals 0. Because what happens when n is 0? It just covers up the pi. And remember from Friday, n can be any number, any integer. Okay, anything on the number line that's a tick mark. So that would be when n is 0. Now you want to keep increasing the n value until you're not on the unit circle anymore. So what you'll have to do for your answer is add pi. So you have to take, your next answer would be the pi over 6 you started with, and you're going to add, well, what would happen if n is 1? If n is 1, you're adding just on the pi, right? So again, that's when n is 1. Now how do you add those things? You need a what? A common denominator, right? So 6 over 6, because its denominator is 1 there. So add a 6 to the bottom. So how many do you get altogether? That's 7 pi over 6. So that's a second answer. So your first answer is going to be pi over 6. Your second answer is going to be 7 pi over 6, because that fits on the unit circle. It is smaller than 2 pi. You only want the answers between 0 and 2 pi. So I'm going to go over here, okay, so that I don't run out of room. And I'm now going to see what happens when n is another number, like 2. So theta is going to be the pi over 6 you started with. Did I stop recording?
I think so. It's not even on.
It's not even on? Okay.
No, that's your password. That's the.
Anybody have a Mac at home?
Well, I guess it's
Oh, I'm still recording. Okay, so I'm not going to edit that out. Those of you who are there, you're just going to have to deal with it. All right? And we'll go back at the end, and if I have to record it again, we'll record it again. Thanks, Justin. This is like what happens when you're like live streaming. I should have like streamed it. I've never done that. Like a Facebook Live, is that a thing? Do you guys do that? All right, so we're going to keep going. All right, so what I was saying was over here, I'm going to add on another n value. And you keep adding on n values until you go beyond the unit circle or beyond 2 pi. So if I add on and change n to 2 now, that would be the pi I'm starting with, and now n is going to be 2. So what I'm doing now is I have to get a common denominator of 6 again, just like I did over here, which gives me pi over 6 plus 12 pi over 6 for a grand total of 13 pi over 6. Now here's the thing. If you were to do 13 divided by 6, we can grab a calculator. Okay, you won't need calculators for any of these. You're going to get better at them. If I take 13 and I divide by 6, that's 2.1666666 all the way forever. That's bigger than 2, right? And I have to stop at how many pi's? 2. So this answer is too big. You only want the answers that fit on the unit circle. So once your answer goes over 2 pi, so with denominator 6, you can have no answers with a top, okay, a numerator, no answers with a top bigger than 12. Because 12 is the 2 pi over 6. So you can tell by adding the numerators. And I'm going to show you again with the next one. So the only two answers for the first equation are pi over 6 and 7 pi over 6. I took what we did on Friday, and I just added the n values. And as you get better at these, you'll be able to do them in your head. Do you have any questions on just the first piece? Because now I have to do that one. I'm going to do the same thing. You know, what you can do in your head is think about where you have to stop. So just as a little note, my stopping point here is going to be, with denominator 3, 2 pi. 3 times 2 is 6 pi over 3. If my numerator thing in front of the pi is bigger than 6, I stop. And now I have to add 3 pi over 3 until I get all of the answers. So the first answer is going to be the one you start with, pi over 3. The second answer, or the other answers, are going to be adding 3 to the numerator. You're going to keep adding whatever you have to add to get to the next thing. So this was n was 0. Now when n is 1, I'm adding 1 pi on. So if I have 1 pi over 3 and I add another one, that's 4 pi over 3. I'm adding 1 plus 3 in my head. What happens if I take my answer and I add on another pi? What if I make n 2 and I add on another pi? Well, 3 plus 4 is 7, right? And 7 is bigger than 6, so I'm done. I found both answers. So I have 4 answers, or normally I started with 2 answers. Do you think that has any connection to the 2 at the top? It does. What you would normally have as 2 answers, that 2 doubles the number of answers, and you now have 4 of them. If you can't do them in your head like I did this one, you can just go back and literally write out all of this work. It's just going to take you a little bit longer. Not wrong, just longer. Questions? Okay, let me show you another one. Let me just change color so it doesn't start to blur. Actually, I'm going to use blue because I don't know if green will show up on. All right. So in all of the problems, remember you have to get the trig function by itself. So I'm going to first divide by radical 3. So this will be the tangent of 1/3 x equals 1 over radical 3. Justin, can we see that on the video? Password again? No problem. It gives them some time actually to catch up because some of them might need time to copy. Okay, we're still recording, and I think you can see it.
Yeah.
All right, great. All right, so I now need to figure out where the tangent is 1 over radical 3. You can rationalize this if you want, okay, but do you remember our little cheater column on our unit circle? Okay, our cheater column on our unit circle, let's first do where tangent's positive, there and there. And tangent being 1 over radical 3 is at pi over 6, right? On your unit circle, remember we made that side where we do the numerator over the numerator? Okay, so at pi over 6 is where it happens. If you still use your unit circle, remember on your quiz, which will be on Thursday this week, it'll be blank. Or someone from my other class asked if they could grab one of those blank unit circles, like to grab like as the test is being passed out. You can do that. Okay, I'm not going to really tell the sub that, but it's literally blank. So, okay, you can always just draw one on the back. So pi over 6, and then this one's 7 pi over 6. And what type of angles are these two answers? Do you remember? They're vertical, right? So do I have to add 2 pi to these? No, I'm going to take, so my answer, the 1/3 x, is what my answer will be equal to. I'm going to take the pi over 6, and I'm only going to add pi into it, because what that does is it scoops up the 7 pi over 6. Get from here to here, you only have to add pi. So if they're neighbors, 2 pi. If they're verticals, okay, if they're on a diagonal, pi only, because it takes care of the second answer. So now, like what we did earlier, I'm going to go ahead and solve for the x in this case. So I'm going to multiply by 3 over 1, the reciprocal, just like here, where we divided by 2, that was the same as multiplying by 1/2. You can multiply to get rid of the 1/3 by 3, if you prefer 3 over 1, same thing. X equals, that'll be 3 pi over 6 plus 3 pi n. Do you have any questions? All right, that reduces. So it'll be pi over 2 plus 3 pi n. And now you have to figure out which answers are on the unit circle. The first answer is always the thing in front of the plus stuff. So the thing in front, pi over 2, is your first answer. Now you have to take that and technically add 3 pi numerous times. Well, isn't 3 pi bigger than 2 pi? So if you take a half and you add 3 to it, aren't you going to be way over anyway? So this is your only answer. If you can see that by adding in your head it's not going to matter, then I told you this would be the day because I'm videotaping.
Sorry.
No, it's not your fault. Thank you. That's someone will come to the door. It's totally fine. All right, so one more time what I was saying was that if you can see that adding on is going to make you go over 2 pi, you don't have to show all the work. You can just be done. And sometimes your reduction of your answer is just your answer. But because you started with yik, you have to do this step first before you can narrow down your answers. You can't just say the answer is pi over 6 and 7 pi over 6 and be done. You have to go ahead and solve it this way to take care of the multiple angles. Do you have any questions? Okay, so if you're here, copy down the third one. I think I have to put in my password, and then I can adjust it. Thank you, Justin. I didn't realize it was going to do that. Let's hope it taped properly. Okay. All right, so here's the third example. Bet you I'm really loud on there. Hold on, right behind it. Hope it blow into your ears out. Okay, for this next one, this is a really nasty yik, okay? All right. So it doesn't matter that there's a really nasty yik. You still just ignore it, and then you're going to solve for where the sign is 1. Okay, so you need to know where the sign is 1 on your unit circle. Do you know where that is? The sign is 1 at? You have in front of you, Skylar, where the sign is the y coordinate.
Pi over 2.
Pi over 2, but that's really it, right? The y coordinate's only 1 at pi over 2. So I have that the 3x minus pi over 4 is equal to pi over 2. It's the only answer. If you have to draw it, you can draw it. It's right here. It's at 0, 1. That's the only spot where the sign, the y coordinate's 1. And there's no other answers, so you have no choice but to add a 2 pi n to the end of that. Can we see the green marker on the video?
Oh, yeah.
Good, thank you. All right, so now like we did on Friday, I still have to get that x by itself. So I'm going to add pi over 4 to both sides. So when I add pi over 4 to both sides, do we remember how I have to add these two things? I have to get a common denominator in order to add those. So for this one, since the bottom one, the pi over 4 is already a 4, I just have to multiply this by 2 over 2 to get a 4. So I have 3x equals, so it'll be 2 and 1 more, 3 pi over 4 plus 2 pi n. That's reducing just those pi's, so adding these up with a common denominator of 4. Then I'm going to multiply through by 1/3. Just like in that problem over there, example 1, I multiplied through by a half. So x equals, distributing through, 3 pi over 12 plus 2 pi over 3n. And you can reduce this if you want. I think I'm going to reduce at the end, because if I go ahead and reduce now, I'm going to go ahead and reduce those out, and I think I'll still need a denominator of 12. Okay, because what would happen over here, just for scrap work purposes, that would reduce to pi over 4, right? And what I'm going to have to do now is add pi over 4 plus 2 pi over 3n. I'm going to have to add these together, and in order to add them, I'll need a common denominator of 12. So you might as well leave it like this, and your common denominator is going to be 12. So let's go ahead and get that over here by multiplying the top and bottom by 4. So now my new solution is 3 pi over 12 plus 8 pi over 12n. And now what you have to do is add 8 pi over 12 over and over and over again. That's what that n value is. You're going to add it over and over and over again until you go beyond 2 pi. So what is my stopping point? I'm going to stop when the top is, well, I have to get it into 2 pi, right? 2 pi is my stopping point. So 2 pi with denominator 12, getting a common denominator there, will be 24 pi over 12. I'm going to keep adding the numerators up until the number's 24 or more. 24 or more is not allowed. So you're going to stop when the top is 24. So here are your answers. Do you have any questions before I write them down? Because I'm going to write them and reduce them. The first answer is always the first thing you found. 3 pi over 12. I'll reduce that in a minute. Now I'm going to take the 3 and I'm going to add the tops. That's how you can start doing these in your head. Instead of writing them all out with n equals 0, n equals 1, n equals 2, you're just going to keep adding 8 pi over 12 to the previous answer. It makes you go around the circle again. So I take 3, the answer I had first, and I add 8 to it. That's 11 pi over 12. That would be n is 1. So n is 0, n is 1. Now if n is 2, you have to add again. So what you do is you take the previous answer, 11 pi over 12, and you add 8 to it. 11 and 8 is 19 pi over 12. How am I doing? And then you have to add more. So if I add more, I take 19 and 8. How much is 19 and 8? Can you do that in your head? 27. Hold on a second. 27 pi over 12. How do you feel about that answer? Well, 27 is more than 24. So that's not really an answer. You only have these 3, which I'm now going to reduce. And then you'd be done. Do you have questions on how I got these 3 legal answers? This one's too much. It's bigger than 2 pi. My original direction said I had to stop at 2 pi. So your actual answer is going to be to reduce this one. It looks like the only one. Pi over 4. And then 11 pi over 12 does not reduce. And neither does 19 pi over 12. So if you can reduce your answers, you're going to want to go ahead and do that. This is the short way of doing what I did the long way in example 1. So this one again was n is 0, n is 1, n is 2, and sometimes you need to go farther. Now I want you to notice something like I talked about in example 1. Did you know this was only one answer of pi over 2 from the beginning of the problem? And what do you notice was in front of that x? A 3, right? And what happened? We went from one answer to 3 answers. There's typically, I'm not going to say 100% of the time because I don't want you to rely on it, there's typically a connection. Okay? So like in this one, what it did was it cut our normal number of answers by a third. That's why we only had one answer here. We could have had more, but it cut the number of answers by a third. Do you have any questions? Okay, great. I'm going to pause the video, and then you guys can start if you want. Come see me in the morning if you have questions. I can't wait to see how ridiculous this looks.